All right, grade nines, are you ready for day 11 of unit 5? This is the last lesson for this unit, and it's an exciting day because not only is it the last lesson of the unit, but this lesson will incorporate almost 2 months worth of work that we've been doing and putting it all together to answer one question. So this is one of my favorite types of questions, and I really hope that you understand what's going on and are be able to replicate the math that we're doing here. This will set you up for lots of success in grade 10. So I want you to try really hard to do well on today's work. So as always, we're going to start with another example talking about rides, but we're going to use a little bit of what we learned yesterday in the last lesson and just go one step further. So we'll look at this scenario here. It says Tara spent $24 at the fair and rode 7 rides. Mary only rode 5 rides and spent $20. And then there's a couple of questions about this. So what we want to do is take the scenario that we have here and represent it with an equation. Okay, we want to model it with an equation. This is where the mathematics comes into what we're doing. Because when we have an equation, we can now answer any question we want about this scenario. But with an equation allows us to do all of this part A and part B. Okay, so I don't want you to go off and try and fiddle around. I actually have a lot of confidence that you could probably fiddle around and try and get these answers, but I want us to practice all the math we've been learning in this one question. Okay, so in order to get an equation, we need y equals mx plus b. We know this. We need a rate of change and a slope. Or sorry, a rate of change, which is the slope, and a y-intercept, which is a flat rate. And in this question, we have neither. Yesterday's lesson, we at least had the slope to start off with and a point, and then we could do some work to get the y-intercept. We're going to do that similar stuff today, but we need to first figure out what the slope is. We don't have the rate of change. All we have is 2 pieces of information. And these 2 pieces of information are enough for us to get a slope and a y-intercept. So let's look at the scenarios. So she spent $24 for 7 rides at the fair. So this represents 1 point in this relationship, 1 coordinate. Okay, so remember, as always, we got our 2 coordinates. This time we have 2 coordinates instead of 1 coordinate because we know information about Tara and Mary. All right, and remember, our time goes first and our money goes second. In this case, time is represented by the number of rides, and money is obviously the cost. So for Tara, she had 7 rides and it cost her $24. Okay, so again, the independent variable goes first, the cost or the dependent variable goes second. The cost at the fair depends on how many rides you go on. And then Mary, her information is given in the opposite direction. She only rode 5 times and spent $20. So 5 and 20. So unlike yesterday's where we had a slope and 1 point, here we have 2 points. Well, once we have 2 points on a graph or in a relationship, we can figure out the slope. So we can do that by using our trusty slope formula. And so just like before, I'd like you to write down the formula every time we use it. So y2 minus y1 over x2 minus x1. The change in y over the change in x. And of course, the change in y is representing the difference between these 2 costs. So let's actually do that math. This is our y2. Okay, so remember, our y2 is 24, and we are going to subtract the 20, where's our y1. So there's a difference of $4 here. And we compare it to the change in x, which is the change in the number of rides. So we have $7 minus the other one, which is 5. And the change of that is 2. So we can go and compare it. 24 minus 20 is 4. And 7 minus 5 is 2. And so we get that the slope is 2. Okay? And again, this kind of makes sense. You see how Mary rode 5 times and spent 20. And Tara rode 2 more times and paid $4 more. So 4 divided by 2 gets us our $2 per ride. And now we have our slope. And the good news is, now that we have our slope, the question is exactly like yesterday's work, where we take our slope and a point and substitute to figure out the flat rate, because again, that's not given information. So we know already we have y equals 2x plus b. And what we need to do is use an x and a y and an x, to figure out the flat rate. Well, yesterday we only had one option. We plugged in the given point. Well, here we have two, and it doesn't matter which one we pick. So for fun, I'm going to choose 724, just because it's Tara's is the first one up there. Okay, but I could choose 5 and 20, and I would get the same answer, because it's the same flat rate. Remember, the same flat rate is the entrance fee. So if x is 7, that goes here, and y is 24, it goes here. We continue with our bed mass, and there's the algebra that we've learned is coming into play. 2 times 7 is 14. And of course, we have to subtract 14 from both sides to get b by itself. B equals 10. And that means the flat rate must be $10 to get in. And we can verify this just by looking at the scenarios. So if Mary rode five times, well, 5 times $2 per ride is $10, plus the $10 to get in is $20. Tara went 7 times. 7 times 2 is 14, plus the $10 to get in is 24. Okay, and so we now have an equation. Y equals the rate of change, the slope, 2x being the number of rides, plus your flat rate of 10. And we've got our equation. So this second half of this is exactly like the work that you did yesterday, and you got an equation. But yesterday's lesson, we stopped there. We just got the equation. That was it. But now that we have this equation, we can answer tons of questions about it. How much would it cost if we rode 10 rides? If you had $40, how many rides could you go in? And this is the whole point on the math that we've been studying. And if we can model this scenario with an equation, we can use the equation to extrapolate and get information that we didn't know before. And we can find out all sorts of other stuff. So modeling it with mathematics allows us to get unknown information, which is our problem solving that we need. So how much would it cost if we rode 10 rides? Well, we did this math a bunch of times. We did it when we were studying algebra, and we did it when we were doing different scenarios in Google Slides. Remember those? So 10 rides, x equals 10. Okay, because rides is the x value. So if x equals 10, we're going to take our equation. It's 2 times x, so we're going to replace that with 10. 2 times 10 is 20, plus another $10 to get in is $30. And therefore, the number 10 rides costs us $30. B, if we had $40, how many rides could we have gone on? So this gives us the opposite question. Now we're given the cost. We're given the y value. So y equals 40. And we take our equation, and now we replace the y value as 40. And we have to solve for x. Again, to do that, we're going to take away the $10 flat rate. We know then that $30 is left over, and that must have been what we paid on the rides. If it's $2 a ride, we divide both sides by 2, and x equals 15. And we can conclude by saying $40 gets you 15 rides. So just look at the screen right now, and you can see all of the mathematics we've been doing for the last couple of months all put together. So the point of this question is sure to get an answer to these questions to solve this problem, but it's also to demonstrate all of the excellent form and mathematics that we've learned to answer this question. As I said at the beginning, I'm pretty confident many of you could do some fiddling and some scribbling to get this. But the point is to not just do that, but to be a good mathematician, use proper form, demonstrate all your steps, get a model, and use that model to answer these questions, including finishing off with a sentence. So your practice today is going to be to replicate what you see here. So I'm going to do another one. So this time we have Regan, who played 6 holes of mini golf for $6, and Klaus paid $8 for 10 holes of mini golf. Again, if you just looked and read one scenario, you might think 6 holes, $6, it cost $1 a hole. But that's not true, because Klaus would have paid $10. So again, this gets a little bit confusing. And as we get good at this math, it allows us to tackle more challenging questions. And this is what you're going to be doing in grade 10 and beyond. So let's not worry about trying to fiddle around. Let's use the proper math to solve this scenario. So we need an equation, we need the slope and the y-intercept. And the given information is 2 points. So again, we've got an x and a y. Regan played 6 holes for $6. So remember, the time is 6 holes and the cost is $6. Klaus, $8, 10 holes. So be careful here. It's not 8.10. $8 is the cost and 10 is the amount of holes you have. Okay? And you can see how the time, or the independent variable, is being measured by the number of holes, and the cost is the dependent variable. So here we have 2 points, just like the other question. No slope, no y-intercept. We have to figure that out. So we have 2 points. We're going to use our slope formula. y2 minus y1 over x2 minus x1. We'll write down that slope formula. Okay, and y2 is the change in the price here, so that's going to be 8 minus 6. And x2 minus x1 is the change in x, so 10 minus 6. All right, let's check. 8 minus 6 is $2, and 10 minus 6 is 4 holes. And so here we have 2 over 4. So interesting, when you look at that, 2 over 4, some people say that's 2. That's not true. 2 over 4 reduces to 1/2. So normally I'm okay with m equals 1/2. That's a very good thing. It means for every 2 that you go on the x, you rise 1. So that's interesting. But in this scenario, we're talking about money. And nobody says, oh, I have 1/2 dollars. They say that they have 50 cents. So in this particular case, because we're talking about money, it does make sense to go to the decimal and say 0.5. So it's interesting. Again, we might not have guessed that or been able to figure that out on our own, but the math brought us to this point. And let's just think for a second. Okay, 50 cents. So Klaus paid 4 more holes and only had to pay $2 for 4 holes. That means they must have paid 50 cents per hole. And that means we've got the beginnings of our equation, y equals 0.50x plus b. All right, we now need a point to plug in. And again, I can choose 6, 6 or 10, 8. I'm just going to choose 10, 8 just for fun. The 10 then is your y value. Oh, sorry, careful. The 10 is the x value, and the y value is 8. Let's do the math then. 0.5 times 10. You know what? I think I'm going to get my calculator out for this one, just to confirm. 0.5 times 10, well, 50 cents, and we're playing 10 times. That should be okay. That is $5, I think. But let's just confirm. 0.5, or if you wanted 0.50 times 10 is $5. Good. Okay, so $5 for 10 holes. But he paid $8 to get in. That means that if we subtract 5 from both sides, it must have cost $3 just to get in. And then 50 cents for every hole that you play. But the math suggests that I've got an m now and a b, so I can put that into y equals mx plus b and get my equation as y equals 0.5x plus 3. And now I can go off and answer the questions. How much would it cost for 15 holes? That means X is 15. So X goes in for 15 there. 15 times 0.5, I'm going to check that. So 0.50 times 15, I think that's $7.50. Yes, $7.50. 7.5 plus your $3 to get in. 15 holes would cost you $10.50. So we finish off, after doing this beautiful math, we finish off with a sentence. B, how many holes could you play for $13? Again, the scenario is getting a little bit more complicated with decimals. This is why we rely on our beautiful math. So we're going to go B, the cost is $13. That means the Y value is 13. So we replace the y with 13 equals 0.5x plus 3. Solve for x. Well, we're going to ignore the 3, so we divide both sides by 3. That's your cost to get in, and it's $10 left over for the number of holes. And so you got to figure out how many holes can you play if you have $10. Well, if it's 50 cents a hole, that sounds like 20. Let's confirm. So here we're going to go 10 divided by 0.50. And yes, indeed, it is 20 holes. So divide both sides by 0.5. And that means that we're able to play 20 holes for a total of $13. So again, look at all of the stuff. Even in a more difficult scenario when we ended up with decimals, relying on our mathematics allows us to be successful. Now, I'm going to draw your attention back to what you did as the intro to these last 2 days. So remember the video we watched about Kyle stacking pieces of paper. The first video was from the floor, and then the next two were from a table. Now, in this scenario, what we have is we don't know how high the table is, and the table is acting like a flat rate. The height is the flat rate of the table plus all of the different papers that you go on. So in this scenario, you see that you have 5 packs of paper is 100.75 centimeters tall, and 12 packs of paper is 142.75 centimeters tall. And now we get more complicated with our mathematics and our decimals. But you'll see that you already watched this video, and now you'll be able to see how similar it is to the work that we've done. So he's taking the scenarios from the first one and getting the coordinates 5 and 175 or 0.75, and the second point is 12 and that. And look at this, y2 minus y1, x2 minus x1, and dividing that to get his slope. There's the y2, y1, x2 minus x1. That's exactly what our slope formula is. And he's figured out then that it's 42 over 7, which is 6 centimeters per stack. And that's the slope. And so now you're going to substitute that and a point to figure out that B. So look, there's that same substitution that you did. He chose to substitute that, subtracting 72 from both sides to figure out that the flat rate, or in this case the height, is $70.75. Okay? So what's great is that all that complicated math that you saw there is summarized exactly how we did it here. Okay? Exact the same thing. Take the points, calculate the slope, then use the slope and one of the points to figure out the y-intercept, take your equation, and then where we can go now is go further and answer further questions because we've modeled it with this equation. All right, so those are 3 very quick examples, and this then is probably your most important practice that we've done so far. Because of all the math that's shown, you're going to go off and answer 3 more scenarios and then a 4th question at the bottom. Now, I'm going to expect that because of all the math that we are doing, you see that all of this writing that's necessary and everything like that. You're not expected to do this on graspable math. It will be more convenient for you to write it out by hand. Okay. But if you are adventurous and you want to try it, you could go and, if you feel really comfortable about graspable math, you could go do a Google search for graspable math, and it'll pop up right away. Oh, there you go. Graspable math, explore algebra, and you can get a blank thing and go insert equation and start writing away. Okay. And if you feel really comfortable of it, there is all the steps that you would do, right? There's your points. There's your slope. There's your subbing your slope in and your point to get your y-intercept. There's your equation. And then answering your questions, substituting x, substituting y, and even writing out the equations. I am not expecting you to do this, but if you feel really comfortable and think you can do it from a blank canvas, then you're welcome to do that and send me the link. What I am expecting is that most of you will feel more comfortable just writing out the points, doing the slope, subbing it in, and answering the questions like this. Okay, and taking a scan of it. I really am impressed with how I took a scan with my phone, and it looks excellent. So the scanning using your phone is a great way to submit your work. This is what I anticipate most people will do. One last thing about our questions. These first three are just different scenarios. The last one starts to go away from the real life and into analytic geometry, which is what this whole discipline of mathematics that we're doing, actual linear functions. Okay, but this question is answered exactly the same, except I give you the coordinates right now. And because I'm giving you coordinates on a Cartesian plane here, you're going to find the equation of a line, just like you're finding the equation for everything else. It's the same math. You're still finding an equation, and here's your point, so you're still going to find the slope in that. But because it's a little bit more abstract, you might end up with negatives in this question, and that would be fine. Whereas negatives in these scenarios don't make sense. Okay, so your first three examples are you're modeling exactly like the two questions I did with you. And the third one is just pure mathematics where you're going to come up with a y equals mx plus b. So good luck with this. I'm really excited to see how well you do with this. This is a great indication on how well you've been understanding all the math that you've been working so hard at in the last couple of months. The best of luck to you.